Now, we want to continue from the division of fractions and also talk about multiplication of decimals. And now for decimals, we're going to take this whole sheet, this sheet of paper as a whole, and then we are going to divide into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we divide this one to this side into 10 equal parts. So in all, if this side is 10 and this side is also 10, we're going to have 100 of the smaller boxes there. Now if I want to go by it in this way, then this one is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. So if I want to continue and say get 1.4, then it means that I'll need this as 1.0 and then add 4 of these to represent the 1.4. So the whole of this is going to be 1.0 plus 0.1, 0.2, 0.3, 0.4 added to this to give me 1.4. But the focus now is going to be that we are going to start from maybe multiplication of maybe 0.3 by 0.5. 0.3 by 0.5. And so how are we going to do that? So after you have guided your kids or your children to divide a rectangular sheet of paper or a square grid, what we call a square grid, you divide into 10 equal parts here, 10 equal parts here to get the 100 smaller boxes. Then let's assume I want to get 0.3 times 0.5. So here, if I want to go horizontally in this way, I can go horizontally in this way for the 0.3 and come vertically for the 0.5 on the same sheet of paper. So if I want to get 0.3, then it means I'll get 1, 2, 3. So I'll shade this to represent the 0.3. So I'll shade like this to represent the 0.3. So this one represents my 0.3. That's the 0.3. Then I want to get the 0.5. So here I'm going to guide them to go by it in this way. So they'll count 5 of that. 1, 2, 3, 4, 5. Also ending here. So maybe we shade in this way. So I have my 0.3 here, and this is my 0.5. So this place also represents 0.5. So for the multiplication, like how it happened in the multiplication of fractions, we said our focus was on the overlapping region, or where the two lines are going to intersect. The two shaded portions are going to overlap. Okay? And so you notice that it is at this point. So we are now going to count the number of regions that will fall within the shaded, double shaded portion. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have your 15 there. Divided by how many regions are involved in all. How many regions are involved in all? So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 multiplied by 10 is going to give you 100. Therefore, it's going to give us 15 divided by 100. And so, we want to convert 15 divided by 100 into decimals. And this, we know, is going to give you 0.15. How are you going to get this? 1, 2. 2 of the zeros there. And that is going to give you 0.15. And this you will know. And so it means that 3 times 0.5 is equal to 0.15. Let's also extend the lesson to another level. At this point, I want us to find 1.5 times 0.6. 1.5 times 0.6. And so what it means is that for the 1.5, you need one whole. Then you pick 5 from this place. You need one whole, and then you pick 5 from this one. And so, if I want to get 1.5, what it means is that I will need the whole here and then choose 5. That's 1, 2, 3, 4, 5. And so if I shade up to this, I'm after 1.5. Okay? So let me try to shade. Okay. So what it means is that this whole shaded portions here is going to represent 1.5. And then I need 0.6. I'm also going to shade the 0.6 also in this way. Okay? So how do I get my 0.6? I'll have it 1, 2, 3, 4, 5, 6. So I'll have my 0.6 also in this way. This time I want to go in this way. My 0.6 is going to be here. So this represents the 0.6. Okay. So now, what are we going to do? You will notice that if you want to get the double shaded portions, how do you get it? It means the double shaded portions will be 1, 2, 3, 4, 5, 6, all this place. 1, 2, 3, 4, 5, 6. Then we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so we have 6 times 15. And what is 6 times 15? That is going to give you 90. So the double shaded portion there is giving you 90. Okay? And then we divide by the shaded portions. That will give us a whole. Our focus is going to be not all this, but the shaded portions that will give you a whole. Or the number of smaller boxes that will give you a whole. And that one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so here is going to give you 100. And that tells us that 1.5 times 0.6 is equal to 90 divided by 100. And if I want to convert this one to decimals, I'm going to have 1, 2. So this is going to be 0.90, which means that 1.5 times 0.6 is going to be 0.90. So that is it for 1.5 times 1.6. This time, I want to consider an example like 1.4 multiplied by 1.6. 1.4 multiplied by 1.6 using the paper folding or the grid method. And so what we are going to do is that since it is 1.4, you need a whole. That is why I have the black here to represent my whole. And I maybe need 4 of these to be added. Okay? So this is giving you a whole. This is also giving you a whole. This is also giving you a whole. And this one too is giving you a whole. So for the 1.4, I'll need a whole, which means that I am going to shade the whole of this. And then 1, 2, 3, 4. Okay, but we need to shade down so that the whole of this is going to cover 1.4. Shade down like this. Okay, so this whole thing here is for 1.4. I also need to get 1.6, and so here I also need a whole. Okay, remember this one I shaded in this way, and so this one I'm going to get this whole at the top here, and then add some 6 here. This one is 1.4, so I had the whole and then added 4 here. So that gave me the whole of this. This time I need 1.6, so I'll need it in this way, this whole, and then pick 6 here. So 1, 2, 3, 4, 5, 6. It will end here. 1, 2, 3, 4, 5, 6. So which means that I'll need this So you will have to do it in this way for them to see. Which means that you need four of these so that you can get the 1 point something, which means it's 2 point something, you need 2 in addition. If it is 3 points, you need 3 of the wholes. But this one is 1 point, so we need 2 of the wholes, get 1 whole and get the decimals out of it. So now, which means that this place is also 1.6. Okay. Now, how are you going to guide them to get the answer? You will notice that from this point up to this point, up to this point, up to this point, it's representing 100 of the shaded, smaller boxes. So 100 of the smaller boxes have been shaded. And then, when we come down here, we are after the double shaded portions. We have it from this point, from here, up to this point, up to this point. So what is the shaded portion? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By 1, 2, 3, 4, 5, 6. So 10 by 6 is going to give you 60. Plus, let's look at this one too. This place, from this point up to this point. So we can have the regions as A, region A. We can have a region A. We can have region B. We can have region C. We can have region D. So you count for region A, which gave you 100. Region B is from this point to this point, this place, and that gave you the 60. Let's look for region D or region C. For region C, it's from this place up to this place, then up to this. So our focus is here, the double shaded portion. The focus is here. So let's count what is the 1, 2, 3, 4. By 1, 2, 3, 4, 5, 6. So 4 by 6 is going to give you 24. Plus the region number D is also from here up to this end to this place, up to this place. So we are counting 1, 2, 3, 4. By 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 by 10 is also going to give you 40. So let's do the addition. This and this is 100 plus 100, 200 plus 24, which is 224. And that will be the double shaded portion. Remember, the double shaded portion always gives you the numerator. And so what are we going to do now? We are after the denominator, and the denominator talks about how many of the smaller boxes gives you a whole. How many of the smaller boxes give you a whole? And that one is 100. So we are having 224 divided by 100. And so if I'm going to convert this one into decimals, then it's going to be 2.24, which means that 1.4 times 1.6 is equal to 2.24. I hope you have gotten the concept. So that is all for multiplication of decimals. We started with smaller decimals and we have built on to others. Thank you. We like to consider the division of decimals. And here, if I have an example like 0.90 divided by 0.15, 0.90 or 0.9 divided by 0.15. So here I have my paper grid divided into 10 equal parts, this 1 to 10, making 100 of the smaller boxes. So that this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 1. So if I want to get 0.9, then it means that 0.9 is ending on this note. 0.9 is here. This is 0.9. This line is for 0.9. That is if I'm going in this way. This is 0.9. If I want to come in this way, this is going to be 0.9. And my focus is on this one. Okay. And the question is 0.90 divided by 0.15. So the interpretation is that how many 0.15s can we get in 0.9? Or how many 0.15s can be taken away? How many times will 0.15 go into 0.90? How many times will 0.15 go into 0.90? And so now that we have located our 0.90, we are looking at the number of times we can find 0.15 in this 0.90. But remember, this is 0.15. Okay, so we are going to count it in this way. Whenever you have 15 of these smaller boxes here, it's going to represent 0.15. If you have 15 of these smaller boxes here, that represents 0.15. So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 1 here. Okay? So the first one is this one. That's the first 15. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the second 15, also ending here. Okay? So that one is also from here, ending there. And then the next 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That one too is ending here. This one ends here. Okay, and this one to start from here, ends there. Then we count another 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That 15 is also ending here. Then we count another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That one is ending here. And then we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You can see we have exhausted the 0.90. And so we are now going to count how many of the how many times or how many of the 0.15s were we able to get from the 0.90. How many of the 0.15 were we able to get from the 0.90? So let's count. We have 1 here, 2, 3, 4, 5, and then of course 6. We are counting. 1. The first one ended here, 1. The second one, 2. the third one 3, the fourth one 4, the fifth one then 6, which means that 0.90 divided by 0.15